Okay, so this next portion is going to discuss how to complete the second question. So notice this is more of an application to our calculus. We are going to compute a couple different ideas about this problem specifically. Some involve calculus, some don't. So let's go ahead and look at the question. We have the volume of oil, which is designated V of t. So we have V of t, which is equal to negative t squared plus 7t plus 60. Here we know t is greater than or equal to 0 and our volume is greater than or equal to 0. The reason why these are greater than or equal to 0 is because time can't be negative and our volume cannot also be a negative value. We either have to have nothing or something in it. So first of all, we want to find the initial amount of oil in the tank. So the initial amount of oil in the tank will be specifically when your time is equal to 0. So we're just going to compute v of 0. Again, no calculus involved here. So we're going to have negative 0 squared plus 7 times 0 plus 60. So this goes to 0, this goes to 0, and we're left with 60 gallons. So again, 60 gallons because we have to have units in this problem. So we're going to have 60 gallons of oil in the tank at time equals to 0 or initially. So now we want to find the time at which the tank becomes empty. So now if we want to find the time at which the tank becomes empty, we're looking for our variable t because that's going to be our time and that's going to be specific in hours. And the time at which the tank becomes empty means our v of t now has to equal to 0. So before we were looking when time is equal to 0, but now we're trying to figure out when v of t is equal to 0. Simply we're going to set this quadratic 0, which will be equal to negative t squared plus 7t plus 60. We can divide off through by a negative 1, so we get 0 is equal to t squared minus 7t minus 60. So all we do is divide off by a negative, which will allow us to easily factor this quadratic. So we'll have 0 equals to 2 binomials. In terms of t, our first sign will be negative. What times a negative gives us a negative? That'll be a positive. Factors of 60 that add together to be negative 5 have to be negative 12 and positive 5. Since we're multiplying our two binomials together, we set t minus 12 equal to 0, and then we set t plus 5 equal to 0. T is equal to 12, and t is equal to negative 5. And these would all be in hours. So the units of these guys would all be in hours. So I hope we recognize at this point that we are not going to have a negative time. We cannot have a negative time. It doesn't work. We can't say 5 hours before it started. That doesn't work. So we know that the only feasible possible solution was that the tank will become empty at 12 hours after the leak occurred. So again, 12 hours post the start. So now we want to find the average rate of change, the amount of oil between the interval of 2 to 5 seconds. So the average rate of change, so here we're looking for average rate of change, is going back to one of our first lectures. Average rate of change versus instantaneous rate of change. This guy is what we're looking for in this. All this is going to be the slope between the 2 points. It's going to be the average value between the 2 points. 2, which is less than or equal to t. I'm sorry, 2, which is less than or equal to. Is it less than or equal to? Yeah, t, which is less than or equal to 5. So here we are going to find the slope between these 2 points. So we're going to find v of 5 minus v of 2 all over 5 minus 2. And this is just your y of 2 minus y of 1 over x of 2 minus x of 1. So that's all this is just computing a slope. So now we find the slope. We're going to have to find v of 5. We're going to have to plug in to find v of 5. Then we're going to have to find v of 2. So v of 5 will be negative 5 squared. Let's make sure we can see that there. Negative 5 squared plus 7 times 5 plus 60. So plus 7 times 5 plus 60. Here that we'll get negative 25 plus 35 plus 60. So all we do is FOIL that out. All we do is expand that out. So negative 25 plus 35 gives you a value of 10. 10 plus 60 gives you a value of 70. So that'll be our v of 5. Now to find our V of 2, plugging in again, we are going to have negative 2 squared plus 7 times 2 plus 60. This will give us a value of negative 4 plus 14 plus 60. Negative 4 plus 14 gives you 10. 10 plus, and this is not plus 160, plus 60. 14 plus 60. Negative 4 plus 14 gives you a value of 10. 10 plus 60 gives you another value of 70. So notice here we plug in, we get 70 minus 70 all over 3, which gives us 0. So we realize that we are changing, excuse me, 0 gallons per hour. So we realize the average rate of change between 2 to 5 seconds is 0 gallons per hour. We realized that there was no change. The volume was consistent at those 2 times, and we know that that's not what happened. We know that's definitely not what happened. However, that's why the average rate of change is not a very good predictor of the change of the volume of our tank. So again, as we talked about this at the very beginning of class, you go back and review your lecture notes about average rate of change versus instantaneous rate of change. The average rate of change is the slope or the average between 2 points, and the instantaneous rate of change actually gives us a specific value of a rate of change at any given point in time. So now part D asks us to find the instantaneous rate of change of the amount of oil at time equals to 2. So we are finding the instantaneous rate of change. So this is going to be the instantaneous rate of change at t is equal to 2 hours. At t is equal to 2 hours. So if we look at this guy, we have that negative t squared plus 7t plus 60. So we have a quadratic that looks like such. So at t equals to 2, we have 60. We know there's a curve that opens down, so it's going to look something like this. And we know that the value that it hits here is going to be at 12 hours. And if this were to have extended onto our negative portion of our x-axis, this would be a value of negative 5 as we saw here. So it would have existed at negative 5 hours if it would have continued on, but we know this only works in the real system because we have the restrictions at the beginning of this problem that t must be greater than 0 and your volume must be greater than 0. So that's why it's only this. So as we just saw in this last example, when t is equal to 2 and t is equal to 5, they're both equal to a value of 7. There's 70 gallons in here. So at t is equal to 2 and then t is equal to 5, this volume is the exact same thing at 70. And that's why the rate of change is equal to a value of 0, because the slope connecting these 2 points is 0. But now we actually want to find the instantaneous rate of change at t equals to 2. The instantaneous rate of change is, by definition, the slope of the tangent line. The slope of the tangent line. At the beginning of the course, we found this using limits. And we designed a chart, and the chart decreased the amount of space, the amount of distance between 2 and 5, then 2 and 4, 2 and 3, 2 and 2, 2 and 0.1, 0.001, 2.00001, and then we ultimately saw that it approached a value, and we did that using that chart format. But now at this level, we recognize that we're just looking for the slope of the tangent line that intersects at point 2, so hopefully we recognize that being the derivative. So we're going to have to find v prime of t. V prime of t means we have to take the derivative of our function. That's just going to be negative 2t plus 7. So taking the derivative of our function, we're just going to get negative 2t plus 7. But we want to find the specific instantaneous rate of change when t equals to 2 hours. So we're going to find v prime of 2, which will equal to negative 2 times 2 plus 7. Negative 2 times 2 would be negative 4 plus 7, so that gives us a value of 3. And again, rate of change, our derivative will always have to be in terms of units. The units here, this is going to be gallons. This is per hour. So this will be gallons per hour. So we recognize that our volume is positive. Positive, when our derivative is positive, that indicates a rate that is increasing. So we realize that we're increasing at 3 gallons per hour, and we do see that our volume does in fact increase. So our volume does in fact increase. So the derivative, the instantaneous rate of change of the volume of the tank with respect to time at time equals to 2 hours is 3 gallons per hour. So now at the last portion, we want to compute all times in which the amount is decreasing at the rate of 13 gallons per hour. But hopefully we recognize here rate and decreasing. So this value that is decreasing is a rate. If we want to indicate a rate that's decreasing, we really know that we're looking for when v prime of t is equal to not a value of 13, but a value of negative 13, because this is actually a vector. This is indicative that the volume is getting smaller and smaller and smaller. So we have to find when v prime of t is equal to negative 13. So here we're going to look for when v prime of t is equal to negative 13. We know v prime is negative 2t plus 7, so we're looking to see when negative 2t plus 7 is equal to negative 13. We're going to subtract 7 on both sides, and that goes away. We get negative 2t is equal to negative 20. Dividing both sides by negative 2, we get t is equal to 10 hours. So if we look on our graph, and I know this wasn't really drawn to scale, hopefully you can recognize that. If this is a value of 10, at this value right here, we recognize the slope of my tangent line at this specific point will be m is equal to negative 13. So again, with this problem, nothing very complicated, only a little bit of calculus. A little bit of calculus we had was taking the derivative. However, we had to know when and why we were taking the derivative and what all of this means. So hopefully this question didn't give you too much of a problem, and if it did, go back and review some of the earlier portions of this course, specifically when we talk about average versus instantaneous rate of change. And then you might actually have to go back and look at some of our algebra and pre-calculus. Thank you.